8 impossible technologies that you need to see. Number 8. Willow Quantum Chip, computing the impossible. Google's Willow quantum chip just solved a problem in 5 minutes that would take the world's fastest supercomputer 10 septillion years. That's longer than the age of the universe. This isn't incremental progress. This is a quantum leap into computing power that defies comprehension. Willow contains 105 superconducting qubits built in Google's Santa Barbara facility. But here's what makes it revolutionary. Unlike previous quantum processors where adding more qubits increased errors, Willow does the opposite. The more qubits you add, the fewer errors occur. This below-threshold scaling solves one of quantum computing's biggest nightmares: error correction at scale. Think of it like this. Imagine building a tower where each new floor makes the entire structure more stable instead of less. That's what Willow achieves. The chip demonstrated random circuit sampling, a computational task specifically designed to test quantum advantage, in under 5 minutes. A classical supercomputer would need 10 quintillion years to complete the same calculation. To put that in perspective, if you started that calculation at the Big Bang 13.8 billion years ago, you'd still be waiting trillions upon trillions of years from now. 6 researchers standing around this palm-sized chip control more computational power than existed in all of human civilization before quantum computing. While Willow can't yet crack RSA encryption or solve practical industry problems, it represents the transition from theoretical physics experiments to actual usable quantum machines that will transform drug discovery, materials science, and artificial intelligence. Number 7. CATL Freevoy Dual Power Battery, Rewriting Energy Storage. CATL's Freevoy battery introduces something electric vehicles desperately needed: dual-zone power management that operates like having 2 separate batteries working in perfect harmony. Each independent energy section has separate voltages, cooling systems, and safety protocols. This isn't just redundancy, it's optimization at the molecular level. The breakthrough is the self-forming anode technology. During the first few charge cycles, the battery builds an incredibly dense internal structure that boosts energy density by 60% volumetrically and 50% gravimetrically compared to previous generations. In practical terms, a battery pack the size of 6 people standing in a row can now store what previously required 9 people worth of space. But energy density is only part of the story. Freevoy supports 12C fast charging, meaning you can charge from empty to full in 5 minutes. That's faster than filling a gas tank. And it operates reliably at -40 degrees Celsius, solving electric vehicle range anxiety in extreme cold, where traditional batteries lose 40% of their capacity. The flexible chemistry pairing is genius. Combine sodium ion with LFP, lithium iron phosphate, for cold weather efficiency, or NCM with LFP for ultra-long range and high power demands. Li Auto, Jassy, and Chery are already integrating Freevoy into production vehicles. When 6 engineers can lift and install a battery pack that delivers 500+ miles of range and charges in minutes, you're witnessing the death of the internal combustion engine. Number 6. TAE Norm Fusion Machine, Bottling the Sun. TAE Technologies NORM Fusion Machine just achieved something that sounds impossible: creating, heating, and stabilizing fusion plasma entirely through neutral beam injection. No complex end sections needed. This is the same process that powers stars, recreated in a device that 6 people can stand around. Previous fusion machines required massive electromagnets, complex confinement systems, and consumed more energy than they produced. NORM simplifies everything through beam-driven field-reversed configuration. Neutral particle beams create the plasma, heat it to millions of degrees, and stabilize it, all in one elegant process. Here's why this matters. NORM uses hydrogen-boron fuel, which produces almost zero radioactive waste. Traditional fusion concepts use deuterium-tritium fuel that creates high-energy neutrons requiring thick shielding and creating radioactive materials. Hydrogen-boron fusion releases charged particles that can be converted directly to electricity without the radiation nightmare. The machine achieves stable fusion-relevant plasma at key temperature thresholds with advanced power systems, active beam control, and real-time feedback stabilization. Norm validates technologies that will power TAE's next-generation Copernicus reactor, designed for commercial fusion energy production. When 6 scientists operating a machine the size of a small room can generate more power than entire coal plants while producing zero emissions and minimal waste, you're looking at the solution to climate change and energy scarcity. Number 5. ESA Future Space Transport Ecosystem, the Orbital Highway. The European Space Agency's future space transport ecosystem envisions something that sounds like science fiction. A network of orbital hubs, autonomous vehicles, and service spacecraft that can dock, refuel, repair, and maintain satellites directly in space. Instead of one-off rocket missions, ESA is building a hub-and-spoke model where orbital hubs serve as refueling depots, maintenance stations, and assembly platforms. Transfer vehicles move payloads between orbits or to destinations like the Moon and beyond, all without returning to Earth. Think of it as building highways in space. Right now, getting to orbit is like driving from New York to Los Angeles on a one-way trip where you abandon the car at the destination. ESA's system creates rest stops, repair shops, and transfer points. The technology development is organized through specialized tracks best for reusable boosters, thrust for advanced propulsion systems, first for breakthrough innovations, in-spoke for in-space mission demonstrations. When 6 astronauts can refuel, repair, and redirect satellites without expensive rescue missions from Earth, you've created sustainable space infrastructure that makes everything else possible. Standardized interfaces ensure interoperability, meaning spacecraft from different countries and companies can dock and exchange resources seamlessly. This transforms space from a destination into a workplace, from exploration into industry. Number 4. Plenty Vertical Farming. Agriculture Reimagined. Plenty is growing food in stacked indoor towers where crops thrive under LED lighting in fully controlled conditions. No soil, no weather, no seasons. The scale is staggering. Plenty's Compton facility produces over 4.5 million pounds of greens annually in a space where 6 people can stand shoulder to shoulder. Traditional farming requires vast land, unpredictable weather, and enormous water consumption. Plenty minimizes land use by over 99% and cuts water consumption by 95% compared to conventional agriculture. Here's what makes this revolutionary. Crops are harvested and delivered to retailers like Walmart and Whole Foods within 24 hours. That strawberry you're eating was growing yesterday. The robotics and AI systems create cultivation recipes, precisely tuned combinations of light spectrum, temperature, humidity, and nutrients optimized for each crop variety. This isn't just about efficiency, it's about possibility. Plenty is building farms in the Middle East, growing water-intensive crops like strawberries in regions where traditional agriculture is impossible. When 6 agricultural technicians operating robots can outproduce 100 traditional farmers using 1% of the land and water, you're witnessing the future of food security. Number 3. Deep Robotics. X30, the Industrial Quadruped. Deep Robotics X30 is a quadruped robot engineered for industrial operations where human access is limited or deadly. This machine operates in temperatures from -20 degrees Celsius to 55 degrees Celsius with IP67 waterproofing. It climbs industrial stairs, handles 45-degree slopes, and steps over 20-centimeter obstacles while carrying inspection equipment. The fusion perception system combines visible light and thermal imaging with intelligent algorithms for mapping, obstacle avoidance, and autonomous navigation, even in complete darkness. In Singapore, X30 units named Spot autonomously inspect underground power tunnels for leaks, cracks, and structural damage. They operate 4 hours per charge with swappable batteries for extended missions. When 6 of these robots can inspect infrastructure that would require dozens of human workers in hazardous conditions, you've eliminated risk while improving inspection quality and frequency. The X30 reaches speeds near 4 meters per second, fast enough to respond rapidly to detected anomalies while slow enough to capture detailed imagery. This signals a new era where robots handle the dangerous, repetitive, and inaccessible tasks while humans focus on analysis and decision-making. Number 2. Ocean Bird Orcel Wind. sailing into the future. The Orcel. Wind is a revolution in maritime transport. A cargo vessel carrying over 7,000 vehicles powered primarily by 6 massive telescoping wing sails. These aren't traditional cloth sails. They're rigid composite structures made from recycled materials, engineered to tilt, rotate, and capture wind with aerodynamic precision. The Wing 560 sail stands 40 meters high, tall enough that 6 people stacked on each other's shoulders wouldn't reach halfway up. This design enables up to 90% lower emissions than conventional diesel-powered vessels while maintaining commercial viability. The wings fold for storm safety and port operations, while advanced weather prediction and routing systems optimize energy use across transoceanic voyages. When 6 wing sails can propel 7,000 vehicles across oceans using only wind power supplemented by minimal auxiliary engines, you're witnessing the decarbonization of global shipping, an industry responsible for 3% of worldwide emissions. Number 1. Skyfall Mars Helicopter Fleet, Planetary Scouts. Skyfall is NASA JPL's vision for Mars exploration. 6 autonomous helicopters scouting, mapping, and searching for water and ice ahead of human missions. Building on Ingenuity's success, Skyfall scales to a coordinated fleet capable of independent and collaborative operations across hundreds of kilometers. The defining innovation is the Skyfall maneuver. Helicopters separate from their descent capsule mid-entry and autonomously land on the Martian surface, eliminating the need for separate landers and reducing mission complexity. Each helicopter carries advanced cameras and ground-penetrating radar to build 3D terrain models and detect subsurface water deposits. When 6 autonomous helicopters can scout an area the size of 6 football fields, standing end-to-end in a single day, territory that would take Mars rovers months to cover, you're revolutionizing planetary exploration. This distributed aerial intelligence provides wide-area reconnaissance guiding landing site selection and mission planning for future human settlements. These aren't just cool robots. They're humanity's advanced scouts preparing Mars for our arrival.